Board was brought in for dead condition, and the customer that brought the laptop said he abandoned the system for quite a long period of time, and when he came back, upon powering the system fails to power. So looking at this board, first thing I will do on this board is to check if there is any physical damage or if it has been worked on. And I've checked carefully, nothing on this board have been worked on, and as per physical damage, no component is damaged. The only clue here is, as per physical issue, is there are some parts there that look somehow rusty, probably due to dust or something, as you can see, even this part of it. And another major one is the IO parts. At this IO parts, you can see these two pins, although I won't place attention on them, but these are just little clue for me as per if I'm going to discharge this board. So before doing anything, all I'll do now is I will have to insert my DC supply. At least the reason why I'm inserting my DC supply is to know what is the status of this motherboard, because the value I'm getting here will communicate to me whatever the status of this board is. Firstly, before doing that, my techniques is normal I work with 5 amps, but upon testing level I have to reduce this 5 amp to 1 amp. The reason why I'm using this 1 amp is because if there is going to be any issue, before it will be difficult for the component to get damaged with this 1 amp, but if I'm using 5 amp, it will be easy for the component to get damaged. So before inserting my adapter, what I'm going to do is I will check if my 19-volt rail is fine, because it can be dangerous for me to use my DC if my 19-volt rail is short. Now I've placed my multimeter on diode range, and I will check what is the value of my CLR rail. I have 453, which means my CLR is fine, so I'm good to go with my DC supply. If I should insert my DC supply here, I'm getting this indicator. This indicator is telling me nothing but at least 90%, like about 95% assurance that my adapter is communicating fine. That is the meaning of this indicator as far as HP is concerned. So with this value here, like I said it passes a message to me as per what is the status of this board. With this value here, this is telling me nothing but my 19 volt is fine, like it's generated, and most likely it's there is very low probability that my standby is present. So but without doing anything, firstly I've detected that okay, this laptop is taking 0.002 and my 19 volt is not fluctuating. So before doing any other thing again, what I'm going to do next is I will check what are the impedance of my coils. All these coil supply, I will check what is their impedance. Now as per impedance level, I'll place my multimeter at my diode range and place my red probe at the ground part. I can pick on ground at any part of the board. This is my ground. Going by the first one, I have 315, which means this is fine. This is my 3-volt line, and the 5-volt line I have 27. I guess this one will need more time to discharge, because in the Yoruba version I've checked this and it's fine. So I'll come back. Even as you can see, the value is increasing. So first clue, I'll place more attention on this part, because this part now I'm getting 50. Okay, so going by the RAM coil, what is my value here? I have 68, 70, 73, 80. This value is still fine as far as it is not short. This is my RAM coil. And going by the battery coil, I have 543, no short, absolutely fine. And for the PCH section, I have 15. With this 15, it means my ICH part 2 is also good. Reason why I'm getting this low value is because this is on the PCB. Me having this on the PCB without removing it, this value will definitely low. Where you can prove that is here. Even here I will have low value. This is 13. This is because this board, this processor chip is on board. If I should release this chip, then I'll have higher value there. So this is CPU coil, and the CPU coil too is also fine. So which other one do I have again? I think I'm good with all the coil. So as per coil level, the impedance of this board is fine. So what I'm going to do next now is I'll insert my charger, and from here I will check what are the available voltages and what are those things I need for my laptop to power. First thing, number one, I need my 19 volt to be fine. I need my standby volt to be fine, which are the 3 volt and 5 volt line, and followed by the IO need to get all the necessary requirement, like it should receive and give out this particular IO as far as power is concerned. And lastly, I need communication of my BIOS. This communication must be fine. So going by that, I will check if my 19 volt is present first on the board, and I can check that at anywhere. I can check that at anywhere on the board. Here, if I check here, I'll place my meter on the voltage range. If I check here, drain of top MOSFET, I'm picking one randomly. I'm picking the CPU one. I have 19, which means 19 is present on my board. Okay. And which other one again? I can confirm if my 19 is generating properly by checking at the switching MOSFET. On this board, this is always the switching MOSFET. This will be the first MOSFET, diode. They use diode as the first MOSFET. Here, let me check the input and output. At the input part of the diode, I have 19.6 volts. At the output part of the diode, I have 19.5 volts. Okay, fine. Now I'll go to the switching part of the diode. I'll check if my gate value is okay. Before checking the gate value, I can check the input and output as well. This is the input of the second MOSFET that happen to be the switcher, 19.5, and this is the output part of it. I have 19.5 as well. So if I should check the gate now, this is where I'll confirm if it is good. Here I have 23.7 volts, which means the gate the switching of my 19 volt is good. So followed by which section? I'll go to the standby section, and at the standby section I'll check what are my values at the standby section. Here at the 3 volt part I have 0 volt, nothing, and at the 5 volt part I have 0 volt as well, nothing. So for the fact that I'm having 0 volts at this standby section, and which is the next section to be powered on my motherboard, so I will have to check the standby IC that happens to be the regulator that controls the two voltages. If I'm to check that this is the IC here, this is the IC here, yeah, this is the IC here, and the number of the IC is RT8206B, RT8206B. So first I will check the requirement of the IC, and for the IC pin 1, okay, I'll start with the input voltage that happens to be the adapter voltage, pin number 6. The pin number 6 is the adapter voltage. If you should check carefully, this is it here, and this is the landing part here, pin number 6. As you can see, this is the VIN. After the VIN is generated, followed by this part here, going to the which pin number 6, I'll have 19 volt there. And at this pin as well, pin number 4, which is the on LDO. On this IC, once you get input for the before this LDO, you all know that after 19 volt entering the standby IC, the IC will generate standby voltage. On this board, there's going to be on LDO pin, and this is also derived from the 19 volt parts. If you check carefully, here I will have, based on this, I will have around 13, 14, 15 volts to be the on LDO, and on this LDO, this IC will release this particular voltage, 5 volts. After this IC release this 5 volts, and this 5 volts will be feeded back again to the IC as the VCC pin, which is pin number 3. So starting from the beginning, I will start with the pin number 6. So let me do that under the microscope so that you have a better view of that. Still the same reading. this is the IC here, and I'll place my probe here. So pin number 4, which is the first pin, the power pin, 1 2 3 4. This is my pin number 4. At pin number 4, is that the power pin? Okay, that's the on LDO. So I'll check pin number 6 first. Pin number 6. This is my pin number 6. I have 19.5, which is present, and the on LDO is the pin I've just checked now. I think that one too is also present. Yeah, this is my on LDO, 13.8, also present. If you check on meter, on LDO pin number 4 also present. So now I should have my LDO voltage, and that is pin number 7. This is 8 pin, 1 2 3. Okay, this is pin number 8, and this is pin number 7. Pin number 7, I'm having 0.9. This is bad. I'm supposed to have 5 volts there. Automatically there will be no voltage at my VCC, which is the pin number 3. Like I said this voltage is feeded. If this voltage is generated, which is 5 volts, now I'm having 0.9. This voltage is also feeded back to the IC pin number 3. So if I should check pin number 3, 1 1 2 3. If I should check pin number 3, I'm having 0.7. This is also bad. So at this part, what I'm going to do next here, the first thing is I'll change this standby IC, because we have to work step by step. Now because this part is failing now, it's affecting the next part, because this will come followed by this, because this will come by getting feeded from this. So therefore it has to work in a step by step manner. So what I'll do now is I will look for a scrap board and I'll change this component. Now after I've changed the standby IC here, this is it. After I've changed the standby IC here, now I will test it, and by doing that, what I'll do is, firstly, before even testing it, I'll check what is the value of my CPU, because at times if you should change standby IC, it might also be faulty. Since it is not a new one, even new one, it is important to check the value of your standby coil. Now I have 473, still good. Here 313, still good. So for standby level, what I'll do now is I will power with my DC. Before doing that, I will place this on my testing range as well, 1 amp, and I will see if there is any. Firstly, if you are just inserting adapter in your PCB, you have to be very careful, because especially when you just change new IC, because things might go wrong. You don't just go in direct, at least you go in slowly. So first precaution, I've reduced my arms, and second precaution, I won't insert it like normal one. I'll just have to go slow. So my DC is ready at 1 amp, and going by that, yeah. So now the consumption is now different. So what I'll do now is I'll check if the standby voltage are now generating. First thing I'll do is I'll place my meter at the voltage range, and I'll check the first coil. I have 3.3 volts, good, and the second coil here I have nothing, but I have 3.3 volts here, still here. Okay, this is my 5 volt line, this is my 5 volt line, and this is my 3 volt line. So now I have my 3 volts and 5 volts now generating. So what I will do now is I'll power the board and see if the board will power. For doing that, this is my switch here, so I can use this ground and this, or let me just do the simplest one and see if it works. Now my board has power and everything is running. Okay, no RAM. So what I'll do now is I'll turn off the DC. Please, RAM. I'll place the RAM. Since it has powered, I will place this on the higher range again and power the board. Okay, good. So I want to see if it will fluctuate. Now I've powered, the board is now fluctuating. With this fluctuation, at least to maximum extent, I believe the display have come. But for doing that, I'll also test the display. This is the screen here. I've turned off my motherboard. Again, I'll give supply and finally, okay, let me use speaker. I can use the multimeter as well. I'll turn this board on again. So the board has come. Let's wait for now. Display has come and everything is working fine. So now I'll couple the system. Thank you for watching. Actually, I charged this board for 10,000 and I collect service charge of 2,000. This is the 2,000. I spent 1,000 for my feeding. You work and make money. That's just it. So like my boss will say, learn more and earn more. You can't learn what you believe you know. So thank you for watching.